Hey guys, so today we will be mostly looking at the whiteboard. We will have a small activity also, right? So we're done with most of the experiments that require acids and bases. Now we are going to look at another small property that applies to both acids and bases. What exactly it is, we are going to see shortly, right? So for today's activity, what I have with me, I have this beaker. It's empty right now. I have this bottle of acid, uh, hydrochloric acid, and I have a small bottle of water with me. So what I am going to do, I'm going to first fill this beaker with water. All right, I'm going to be filling it up just a little bit. I think that's more than sufficient. All right. So what I'm going to do now is I have a small amount of water to which I will be adding my acid. Okay. I'm simply adding water to acid, right? It's kind of just mixing. But I want to see, does it create any chemical change, anything that I can notice, right? So it's not something maybe you can observe, but probably I can. All right. So whenever you take a strong acid, right, this activity needs a strong acid, which this is, right, hydrochloric acid. Now once you take the acid and mix it up with the water a bit, if you do the activity slowly, you will see that this base of this beaker, right, it's going to start to become warm, right, it's going to become slightly hot, right. If you remember correctly, there is a name for a reaction that generates heat, right, exothermic reactions, right. So whenever I add acid to water, it's an exothermic reaction. But you must be wondering, what is the reaction? It's still white. I mean, it was all not white, colorless, right? It was colorless, it's still colorless. I can't see anything. I don't see anything changing, but it is. Because of the temperature, I can tell. But visually, what is happening is what we are going to try to understand, right? So for this activity, both acids and bases work pretty much in a similar way. Okay, so we are going to see what happens when acids or bases are added to water, right? So we know that water is nothing but H2O, correct? Now I know that I am dissolving my acid and my base or my base in water, right? So I know that water is my solvent here. One thing you need to know about water is it's called as a polar solvent, the meaning of which you are going to understand very shortly. All right. Now I'll talk about two things, one acid and one base. So for my acid, I will take HCl, and for my base, I will take NaOH. Right? These are the ones that we do our activities with. Okay, this is nothing but hydrochloric acid, that is sodium hydroxide. Okay, first we'll look at the activity that we just did, which is acid and water. What happens when I add HCl to water? Okay, definitely it dissolves, not visually we can't see it, but what is happening is there is that heat generated, right? That heat is generated because of some change occurring inside of that beaker. What that change is, if you see polar solvent, by polar we mean to say poles is like having opposite charge, or any sort of a charge is called having a pole, right? What water does, it is going to break any solute, okay, into parts or into polar parts. Okay, right now if this is the solvent, this is the solute. So the water pretty much would stay as water generally. And what happens to the HCl is it gets broken into its two main parts, okay, that is H and Cl. If you remember, when we did crisscross method, we saw like H plus one ion, which is a cation, then we saw Cl minus, which is an ion, a negative, right? So this is basically the reverse of crisscross. You have the compound, you break it apart. So it will create H plus ions, okay, plus Cl minus ions, okay. So hydrochloric acid is broken into hydrogen ion and chlorine ion, both of the constituent atoms. I call it ion because it has a charge. Okay, this charge is what makes it polar. So you understood what polar solvent means, right? It dissolves anything that is polar and splits them apart. Okay. Now generally what happens with this reaction is H plus is usually a little unstable. Okay, so it's going to go and combine with this water and it creates something called as H3O plus, and the chlorine stays as chlorine. So H and H2 becomes H3 and the plus charge gets added on top, H3O plus. Now this is called hydronium ion. Okay. Not very essential to know right now. The main thing you need to know is HCl can be changed into hydrogen ion plus chlorine ion. But this is also mentioned in your book, so I am going to tell it to you. Alright. So I know that HCl can be broken into its constituent parts. Same way I can tell NaOH is also breakable like that. So if I have NaOH plus H2O, I think it will be easy to guess, right? We look at the same part. How did I get NaOH? With crisscross. Which two parts are there in NaOH? There's Na and there's OH. So I'll simply split them apart into those two. Now I know that Na is nothing but Na plus. When I write plus, I mean to say plus 1, okay? If it's more, okay. If it's 1, you can just keep it as plus. It means the same. Plus the remaining part, that is OH, which is OH minus, and the water stays as water. Hydroxide, this is hydroxide ion, which is generally stable, so it won't combine with water. Alright. So the main thing you need to know about NaOH is NaOH can break into its two poles or polar ions, or simply ions, that is Na plus plus OH minus. As simple as that. Okay, break them, put the right charge. Keep in mind the first one always has positive charge. So over here H is positive, Cl is negative. Na is positive, OH is negative. Okay. Now this applies to every base, every acid that you can find in your reader or anywhere. I can go with another example which will also help me show you another property. Okay. Let's go with H2SO4, sulfuric acid, right? Now again the first part is H, the second part is SO4. So I will say H plus SO4. Now if you recall, SO4's charge is 2 minus or minus 2. Okay, so keep in mind it is 2 minus. Now there is SO4 and there is SO4, there is H2 and there is H. So I simply need to balance it. I'll write there are 2 hydrogen ions and 1 SO4 2 minus ion. Alright. That is why the 2 somehow comes here, because 2 of these ions combine with 1 ion of this to give me this. Just in reverse, I do it, I'm going to get this. Cool. So one key observation you need to have is every acid has this H plus ion. Okay, this H plus ion is part of every acid. That's what makes an acid acidic. This H plus ion is what gives it acidity, its strength. The whole effect of an acid is nothing but this H plus ion doing its work. It just gets super reactive and starts to break everything, right? Same goes with base. OH is nothing but hydroxide ion which is there in every single base, right? So for example, let me give you another base, calcium hydroxide. Okay, CaOH twice, that is calcium hydroxide formula. Now again, if you remember, the crisscross, the bottom 2 comes from a double charge, like this 2 came here, same way. Calcium's valence is nothing but 2 plus. Now that is the positive ion and the negative ion, right? Now again there are OH is there twice, so I will just write as 2 OH to balance it out. Alright, now again another observation, both of my bases have OH minus ion, or even in the formula they have OH at the ending. Even for bases the reactivity comes because of this OH minus ion. That's what gives bases or acids their strength. The main thing that we learned, how can I break any acid or base into its constituent ions, which usually water will help us do, and also what is common for every acid and every base. H plus ions for acids, OH minus ions for base. Right, that's what gives them the strength. And also, since they have a charge, they also can help in current to pass. Okay, so later on you'll be learning that current passing is nothing but charge moving, right? And because this is a charge, or has a charge, it can help current to pass through. Meaning if I have like an open circuit, or if I have a circuit and I just dip 2 wires in it, then it will mean that if I pass current, it's going to pass through the liquid into the wires. It's okay, at some point of time we'll see that activity anyway, so that time we can understand. But just know for now that because of ions, these solutions will allow current to pass. Okay, not just the base, it has to be added in water so that it breaks down into its 2 ions. Right, so that's it for today. I hope you liked it, understood it. If you have any questions, you can just drop a comment below. And that's it for today. Thank you. I'll see you tomorrow.